Okay, so here let's start 13.3. So what's happening in this lesson is this. Actually, you've already done this in the right triangle, so it should be easy. But instead of just staying within a right triangle always, what we need to do is look at any angle that we want in one revolution or even past one revolution, and then be able to find any of the 6 trig functions that it has. So what we need to do, first look at this angle theta in this picture. So I already have x and y coordinates and I have angle theta. On the terminal side of the angle, just choose a point. It really doesn't matter which point on this terminal side. As long as you choose a point on the terminal side of this angle, then it's a point, therefore it has x and y coordinates. How do we find xy coordinates? If you come from this point P down perpendicular to the x-axis, then the length that we see here is the x coordinate, and if you go perpendicular to the y-axis, the length that we see here is the y coordinate, which is equal to this one. So this is also the y coordinate. Okay, so once we do that, then this hypotenuse, let's call it r, then you see that we already formed a right triangle here. And in this right triangle, the Pythagorean theorem says what? X squared plus y squared equals hypotenuse squared, in this case r squared. So keep that in mind because that's the relation between x, y, r. Very, very important to keep in mind that x and y, we're referring to the coordinates of the end point on the terminal side of the angle, and r is the hypotenuse that we are making. Or in other words, it's the distance from the origin to the point P on the terminal side of the angle theta. So understanding what x and y and r represent, keeping this picture in mind always. Now for the angle theta, we should be able to define all 6 trig functions as a relation between x, y, and r in this way. So yes, if we just want to look at this as a bunch of formulas, it's going to be difficult to memorize and confusing to remember, okay, which one is what are we doing? But remember that what we are doing, since we already formed a right triangle, then it's the same approach as the right triangle that you've done before. Remember that before in a right triangle where we're studying, we said if this is angle theta, and let's call these ABC, at that time we used the labels ABC instead of X, Y, R. It doesn't matter, those are just names. And then we said that for the angle theta, sine is always the opposite side divided by hypotenuse. Well, opposite to theta would be side B over C. But it's just opposite side over hypotenuse. Cosine of theta, we said that it's adjacent over C, over the hypotenuse. Well, to angle theta, adjacent would be this angle, this side A, and hypotenuse we labeled it as C. But this is nothing but adjacent side over hypotenuse, and so forth. So this was just a quick reminder for you. But it's the same thing here, exactly the same thing. Look at the picture that we had at the beginning, this one. Now here you see that just focus on this right triangle that is formed by x, y, and r. Now if I'm looking for sine of theta, didn't we say sine is opposite over hypotenuse? Therefore opposite to this theta is y and hypotenuse is r. So that's where this sine of theta equals y over r coming from. Cosine of theta, we just talked about it as a reminder, is adjacent over hypotenuse. Well, in this right triangle for angle theta, hypotenuse is r and adjacent side is x. So therefore cosine of theta is x over r, adjacent over hypotenuse. Then tangent of theta is opposite over adjacent, so in this case y over x. And then you know that the 3 that I wrote on the right side, cosecant of theta, secant of theta, and cotangent of theta, are reciprocals of sine theta, cosine of theta, tangent of theta, respectively. So just keep in mind again that xy are coordinates of the point we chose on the terminal side of theta. The relation between x, y, r is that x squared plus y squared is r squared. And we are doing the same approach as right triangles. Now, because we want to make this easier to just memorize, this is some silly hints that I'm going to give you. So here's the picture. We have angle theta here. We have point P on the terminal side, which has coordinates x and y. Therefore, I've already marked x and y for you. Now, since we are looking for sine of theta, look, sine has this I. So if I continue this I, if I extend it, this looks like the y-axis. So sine of theta is related to y coordinate, and it's y over r. Then if we are looking for cosine of theta, here is letter C. If I extend it, looks like x-axis. So cosine is related to x coordinate that we're working with. Tangent of theta, well, here is t. You see that I went for t. Here is this side, which is like y-axis, and here's the other one if I extend it like x-axis. So basically what I have as t of tangent, this would be y over x. So we have y over x for tangent of theta. Okay, so then knowing this, knowing sine theta, cosine theta, tangent theta, and knowing that the other three trig functions, namely cosecant, secant, and cotangent of the angle, are reciprocals of sine, cosine, tangent, then if you already know sine, it means you already know cosecant. Because cosecant of theta is reciprocal of y over r. Just flip that over, you get r over y. Here, cosine, we found it. So secant of theta is reciprocal of x over r, so it's r over x. And for tangent of theta, reciprocal is called cotangent of theta. So reciprocal of y over x is x over y. In the next video, I'm going to explain exactly what we do with these x, y, r, and how we find the 6 trig functions if they exist for different angles depending on their location in different quadrants.